Alright, exponential functions. Congratulations to those of you who did well on the test in Chapter 3. Great job. Those of you who are struggling, keep working at it, keep trying. You'll get through it. This is a new chapter, new material, so let's start over and let's work on our grades, alright?
That's nice. I was expecting something. Yeah, I'm really proud of you. It's the nicest thing you've ever said. I just want to let you know I appreciate it.
Okay, well,
It's over here, bro.
alright, so let me should I have said...
No. Stop there. Stop there. Don't.
Like what you usually say, good luck to the people who succeeded and the rest of you just suck.
That's what I was expecting.
Okay, let's focus on this chapter, alright?
That's for you too.
Exponential functions, really what we're talking about are functions that take this form. Where a is just a real number. We're talking mostly about real numbers this chapter. Leave the imaginary numbers behind for a little bit. But we're also going to be hitting on natural logs and logarithms, which I really like working with that stuff, so hopefully if you struggle with it, you're going to get a little more out of it. We'll be showing you how to do some stuff. But until we get to that point, I got to show you some simple stuff. So today is kind of a simple way of doing exponential functions, alright? What I want you to do is show me that you can use your graphing calculators. You're going to plug in some information. So we're going to, the base is 3, our exponent is going to be x plus 1. So I want you to come up with all the different values that I give you. So when x is negative 1.5. So this is what you should do for the first one. You have 3 raised to the, and it's a group of things. So we need our grouping symbol, negative 1.5 plus 1. And everybody put that in. And you should get 5.5774. Okay? Make sure you can do this. So I can do this. I need to know that you can do it. So I'm putting it up there so that you can see that you're doing it correctly. So this is all the basic stuff. I need to make sure you can use your graphing calculators. Any questions so far on how to put that stuff in? I did not get that answer. Excellent. See, we're already doing great. Okay, now you put these in. And you show me what you get. I'll put them in here in a second. See? See how you guys do.
So then you're taking 3 and then putting. You got it now?
That's just the answer when you put negative 1.5 in for x.
Yeah.
Yes. Yes, that's right. When y is negative 1.5, when x is negative 1.5, y is 0.5774. Or are we still struggling? Alright, well let's find out. Struggling? Well, what'd you get? Where's your graphic calculator? Where's your calculator? Huh? Or you can share, I don't care. But you need to be able to do it by yourself. Okay, let's see if you got what I get. Square root of 3 plus 1, so 3 raised to the square root of 3 plus 1. That's what it should look like right there. If you didn't put the parentheses around the 3, then it's the square root of 4, which would have given you 9. Square root of 4 is 2, 3 squared is 9. Okay, so you have to put it in like that. 20.1149. Got that? Who did not get that? All right, excellent. All right, the next one is E. 3 to the E. That would be second division symbol. Oops. Sorry, we need a grouping symbol. So the second, the division symbol gives you E, and plus 1 division symbol. So F of E. So this is, we're putting E right here. Emily. So whatever's in these parentheses goes in this position. Okay?
Oh, okay.
Alright. 59.43897. Okay? And then the last one, negative 5/4. Notice they use a double parentheses. So I gotta group the fraction together.
What's
God
bless you.
Nah, you guys
I
are so
mean,
caring.
you got it. Do I get extra credit for blessing you?
Yes, sir. Alright, so this is just to show you how to put it in your calculator. Next thing, I want you to graph this. This is number 16. F of x equals 3 to the negative x. Everybody graph that. 3 to the negative x. I have my x-axis window from -5 to +5. So yours is going to look a little bit different. -5 to +5. You don't have to do that. Okay, so just curious here, what is your domain?
Then why did you ask?
What x values won't?
How do you get the negative x?
That's just the problem. 3 to the, oh, but the negative is your, right below the 3, the key. If you have the same calculator. Got it?
We have it, thank you.
Alright. Alright, so you gotta do domain and range. It's on the quiz tomorrow. You gotta make sure you understand this. Domain would be all my x values. This line goes on forever this way, it just gets closer and closer to the x-axis, or the asymptote y equals 0. You gotta know your asymptote too. Now it looks like this might have a vertical asymptote, okay, but it doesn't. I can continue to put any number for x in, and I will get a value. If I put -1 trillion in, this becomes +1 trillion, and 3 to the trillionth power is going to give me a number. Okay, so there is no asymptote here. This is just decreasing. All right, now everybody put this one in. 1/3 to the x. And tell me what you get. You're in trouble. That's all right.
Chill.
Oh.
They did that with the last one, I just thought it was the last one.
Alright, let's just reset. Try it. Oops.
I got one.
Twins.
Oh, I did it again. Alright, I'll do it again. Try it. Okay. What happened? What'd you get? Same thing, right?
Yep.
Well, isn't this a negative exponent? Doesn't that make 1/3 to the x? And you distribute that exponent. 1 to the x is still just 1. So it's still 1/3x. It's the same thing. Okay? Alright, so having said that, keep all this in the back of your mind. Example 18. Everybody graph this. Clear that out. Graph 2/3 to the x. Graph 2/3 to the x, everybody. You'll need grouping symbols. just like that. I'm going to put it on a normal screen so you can see it. Anybody not get this? We need to get moving. Okay, it's decreasing. Now, I want you to compare it to this graph. Everybody put in 4/3 to the x. G of x is 4/3 to the x. I want you to show me what the difference is, or tell me what the difference is.
Increasing.
There's 2/3 to the x, and there is 4/3 to the x. What's the difference? Yes, one is decreasing and one is increasing. Very good. Look at the actual equation and tell me what the difference is if you can. What do you? What? Oh, okay. So if A, the base, is between 0 and 1, it decreases. And if A is greater than 1, it increases. And that would be a true conjecture. Okay? Got it? No? You understand? Oh, well, that's a problem. See.
You're gonna work.
Well, yeah, you got to. Okay? Yes? Yeah, I bet. Okay, now, let's go backwards. Let's find the equation given the graph. We like to go forwards and backwards in math, so here is a graph, and the graph is like this. I want to know the equation. So f of x equals a to the x. What you have to find is a. How we find a is, I'm going to go back and forth.
That's fine.
How we find a is we need x and y. Really, this is y equals a to the x. Everybody understands that f of x is just y. Do we know x and y? All we need is a point on the line. This is -1 and 1/5. So you're going to be given a graph. Pick a point that's on the line. Y is 1/5. We don't know a. X is -1. Can I solve for a at this point? How do I get rid of the -1?
Reciprocal. No?
Put it in the, it would be 1 over 8 in the first.
You get the right answer, but that's not really what you're doing.
1 over 8 in the first.
So 1 over 5, this is 1 over a. What happens is you move this to the denominator. It's not the reciprocal. It happens to be the reciprocal here, but that's not what we have, okay? And then you cross multiply or just tell me what a is. What is a? A is 5. Alright, so then you rewrite it as f of x equals 5 to the x. Okay, let's try another one. This is number 22. Here's your graph. Don't use a 0 for your point. Okay. Don't use intercepts for your points. So this is -3, 8. Now you do the same thing we did over there and see if you can figure it out. It is not possible for me to show you every possible algebra equation and how to solve it. You need to know how to manipulate all types of equations. So I'm showing you 2. I'll help you get started. How many got that far? The rest of you are good now, seeing how it's set up? Okay. See, we're making progress. That's good. You done? Well, first of all, you need to make the negative exponent positive. No, it's not the right answer. A equals 1 over a cubed. Cross multiply. Divide off the 8. So I'm just going to turn this around. A cubed equals 1 over 8. How do I get rid of the cube? How do you get rid of a square? Yeah, so we need a square root. So you're going to take the cubed root. I'm glad this is only 4th grade because I wouldn't want a bunch of juniors and seniors not knowing how to answer that question. Alright, what's the cube root of 1? 1. What's the cube root of 8? 2. So your equation is f of x equals 1/2 raised to the x power. Oh. When we're done, I'll do some more. Okay? Alright. I need you to do a bunch of things on your graphing calculator. So I'm going to set up I want you to put these in your graphing calculator. Oops, sorry. I want you to do one at a time. First of all, tell me what's happening with this setup. What is happening to A? Huh? A is getting smaller. When your denominator gets very large, that whole number gets very small, close to 0. So you're going to put these into your graphing calculator. So we have 1 over 2 dx. Graph it. Oops, I didn't want that other one in there. Hold on. Alright, so there's 1 over 2 to the x. Notice it goes to the y-axis at 1. Why is that? If it goes to the y-axis, what is x?
0.
0. If it's going through the y-axis, x is 0. Well, if x is 0 in each of these, what's anything to the 0 power? 1. Okay? So all of these are going to go through the y-axis at 1. Unless I add or subtract something from x. Alright, now, go back and put in 1/3 to the x. Tell me what happens. And then 1/5. 1/10.
Man, you got an ace on that dartboard.
It's a tank. Shut this down.
So what happened? As A becomes small,
Gets steeper.
closer to 0, yeah, it's steeper. Okay, having said that, keep going and put these in. Yeah, you're supposed to be graphing it. Now what's happening with these? What's happening with A here? What's happening with A? Getting closer to 1. I'm not going below 1 there. So graph each of those and tell me what happens.
Move the other way.
But as A is large, it's very steep. But as it gets closer to 1, it gets fatter. He said fatter. That's funny.
It was funny the way you said it the second time.
Notice that they all go through 1 on the y-axis. Okay? Everybody got it now? That's important. It's also in your book. Now, we got 4 examples for you. Number 1, I want this described. Okay? Describe to me what happens to it. I want the domain in interval notation. I want the range in interval notation. And I want to know the equation of the asymptote. And you got to graph it. On the quiz tomorrow, you will not have a graphing calculator. By the time you are done with your assignment, you will know what the graphs, or should know what the graphs look like. By the time we're done with these 4 examples, you should know what the graphs are going to look like. So trust me. So far, if A is between 0 and 1, it was decreasing. And if A is greater than 1, it was increasing. So that should be something key to you. All right, so put this in your graphing calculator to see what happens. Let's clear all these. And put in 10 to the negative x. Make sure you use the negative key, not the minus sign. Describe to me what happened.
It decreased really steep.
Yeah, it decreased. Why did it decrease? Isn't A bigger than 1? Oh, yes. Negative exponent really reflected it about the y-axis, didn't it? Yeah. All right, so that's important. How does it reflect? Y-axis, x-axis. All right, so now you have the graph, and that graph is really not a very good graph, so I'm going to change my window. Actually, I'll just zoom. Goes through at 1, and then it goes all along. All right, so what's my domain? Are there any x values that won't work? Can I put any x value in here, and will it work?
Yes.
Yes, it will. All right, so my domain, the interval notation is negative infinity to positive infinity. What about my range? And I always do the smallest values first. Will any of my negative y values work? No, why not?
It never even touches it.
Because your graph never gets through the x-axis. So will 0 work? Anything greater than 0? Greater than 0 will work. So we start at 0 and we go to the positive infinity. That's my range. So it has everything to do with what your asymptote is. What is the asymptote? What does the graph approach? Your end behavior, what does it approach?
0.
0. So y equals 0 is my asymptote. Again, it appears that there's an asymptote somewhere right in here, a vertical one. If that were the case, then there would be a number I could not put in for x, but there is not a number I can put in. There is not a number I can find that will make this incorrect. Okay, I can put anything. If I put in -4, that becomes 10 to the 4th. That's a number. If I put in 10, -10, which is way over here, but 10 to the +10, that is a real number, isn't it? So it appears that there is a vertical asymptote, but there is not. So you have to use your brain a little bit. This is kind of like what the quiz is tomorrow, but I'm going to make it a little harder. Example 28.
How come?
Because I don't like it.
Well,
Like,
at
that's
least you're
completely
honest.
obvious.
Alright, first thing I want you to do is you're going to graph it, and you're going to... Oh wait, don't graph it yet. I want you to graph 2 to the x first. And then we're going to talk about the domain, the range, and the asymptote again. Alright, so first of all, let's put up on the screen 2 to the x. Everybody do it with me. There's 2 to the x, and I'm going to have to zoom out, so I'm going to put it on a regular screen here. There's 2 to the x. Now, everybody put in 2 to the x minus 3 and tell me what happens. Don't forget, you need, that's the grouping symbol. What happened? Yep. Just write 3. What's my domain? Can you find an x value that won't work?
No.
Okay. Negative infinity to positive infinity. What about my range?
0 to
Yeah. Not including 0, but to positive infinity. Everything positive, all your positive. That's how you would say that. Don't worry, that's going to change. What's my asymptote?
0.
Show me. Yeah. It's approaching 0, but never touching. Excellent. Let's make it harder. Example 30. H of x equals 6 minus 3 to the x. I want you to first graph negative 3 to the x. Then we'll talk about the rest of this stuff. Graph negative 3 to the x. Clear all this other stuff out. What happened? It went down.
Try to go low, low, low.
Reflected about the x-axis. So 3 is still larger than 1, so it's an increasing function, but when you were put a negative in front of it, it shows that it's decreasing below the x-axis, okay? Alright, having said that, watch what I'm going to do here. I'm going to put this positive 6 over here. Put that on the second line and graph it and tell me what happens. Ah. Yep. Notice I didn't put any grouping symbols around it. There's negative 3 to the x. Negative 3 to the x plus 6. Anybody else? Up. It went up. that thing. Let me see what you have. Oh, you put the 6 in the exponent. That's why it went left 6. It's not in the exponent. So don't put parentheses in that if you have the school's calculators. Okay. So it shifted up. Okay. What's my domain? Are there any x values that won't work? So negative infinity to positive infinity. What's my range? Start at the bottom. Do I have y's that work right here? Are there y values?
Infinite.
Infinitely negative up to what?
Is that 5, 6?
Up to 6. Why is it going through the y-axis at 5? Well, when x is 0, 3 to the 0 is 1. 6 minus 1 is 5. You should be able to tell me where it's crossing the y-axis when you graph. Without your calculator, you have to do this. Now, you ready for me to help you? No?
Yes.
Okay.
Yes.
All right. So here's what you should be learning from all of that stuff. So we've been working up to hopefully have an understanding of what happens in these exponential functions without using our technology. So what we have here is y equals plus or minus a to the x minus h plus k. There's your h and k again. This is your reflection about the x-axis. If it's positive, it's going to be above. If it's negative, it'll be reflecting over the x-axis. If it's negative, it's going to be underneath the x-axis, reflected about it. It'll be a reflection. Okay? This tells me if it's left or right. Remember, it is the opposite of what the sign is because it's in a grouping symbol. Remember that? And this is telling us how it shifts up or down. And it is exactly what that sign is. If it's positive, it shifts up. If it's negative, it shifts down. All right, so after you do your homework tonight, this should be a little more familiar to you, so that when you take the quiz tomorrow, you can just do it. All right, so everybody do this one without your calculator. This is example 36. Let's see if you can do it. H of x equals 2 to the x minus 4 plus 1. I want a description of what's happening. I want you to graph it. I want the y-intercept, domain range, and asymptote. So, description, graph, domain, range, and the asymptote. All right. Who can tell me the description?
Shifts right forward.
Yeah. To the right 4 and up 1. Right 4, up 1. Okay, so that tells me that my asymptote is not at y equals 0, it's at y equals 1. This is positive, so it's going to be above that asymptote. 2 is bigger than 1. It's going to be increasing. And it shifts to the right 4 units. So you can't tell me the y-intercept because it doesn't go through what we would assume to be 1 because it's shifted over 4 units. But you should be able to tell me that point, which is what? 4, 2. 1 unit above the asymptote. Right? If x is 4, 4 minus 4 is 0. Right? That's 1. 2 to the 0 is 1. 1 plus 1 is 2. So 4, 2, that's going to be a point. And then it goes up like that. So you got the graph. Domain. Negative infinity to positive infinity. Range. What's your range? It's not including positive 1, not including 1, but just above 1, all the way up. That's your y, those are your y values. And your asymptote should be y equals 1. Okay. So tomorrow you may have a fraction here, left between 0 and 1. It may be a number bigger than 1, but you're going to do this on your quiz. Okay, so after you work through the problems and you have your answers to look at, hopefully you'll be familiar with it and be ready for the quiz. Your assignment. Page 308, 5 to 45 odds, and 59.